Hi, welcome to this lecture. And this lecture is on queries involving multiple tables. If you remember, in the last lecture, I went over the concept of multiple tables. The point was that if you put too much of information in one table, then that may result in problems like anomalies, and we looked at update anomalies, and we realized the fact that the reason behind anomalies is redundancy. So what we should be doing, rather than putting the information about more than one entity in one table, we should try to split in multiple the data in multiple tables. So now we looked at some example. So one of the example was the uh, table involving shares information and the table involving nation information. We were working on that data, and for that I already provided a couple of files on Blackboard. I requested you to create tables based on those two files. One file is for shares, it is called shares2 file, and then we have one file called nations file. So we have already looked at this concept that very often we will be having more than one table for our database, and we looked at a little bit about the RDMs. We did look at how to create an RDM using MS Access. So that's what I did, and hopefully you tried that, and you were also successful in creating the RDM the way I did. Okay, and that is something which you can do using MS Access. Alright, so now in this lecture we will learn about writing queries when you have more than one table. And one more thing that we learned in the last lecture was about the concept of relationships. So since in the last lecture only we were dealing with two tables, so we looked at the interactions or um, association, right? You can either say the interaction or the association between different tables or entities is defined in terms of relationship. So we defined relationships, and the example that we were looking at was an example of one to many kind of relationship, right? And we also looked at multiplicity. So fine, so these things we have already seen, and we have a decent understanding of one to many relationship because we are working on a data or working on those on two tables where we have one to many relationship, which is between the shares table and the nations table. So in we have one nation, we have sorry the nations information and shares information, and the relationship is such that in one nation we have multiple shares listed. So there is one to many relationship between nation and shares. Okay, so the queries that we will be learning to write in this lecture would be around one to many relationship. Okay, so the interesting thing that we have is that the queries are almost similar, except for one new thing you'll be learning in this lecture, which is the concept of join. Okay, so let me see what do I have in my lecture. I will be using my pen as usual for my notes. Okay, we will write queries for the database with one to many relationship that we have seen, and the queries that we'll be writing would be multi table queries. These are similar to what we have written in the that's what we have learned while we were writing one single table query, but there will be some difference, right? Minor difference, so I'll tell you about that. And that difference relates with the join. When you have more than one table, then you want to combine those two tables so that you have the combined information, and then your query is done on the combination of tables. So this combination in databases is called joining. Okay, most in relational databases when you combine two tables for your query, then that we call that as join operation. So we'll learn about join operation. How should we perform join? Okay. All right. So let's revisit the example that we had, because the queries that I'll be writing would be based on these two tables. So this was one. Okay, that was one, and this was many, one to many kind of relationship we have here. So let's look at the nation. What do we have in nation? In the nation, we have the information about a country. The ID is the primary key or the identifier of nation. You have a code which can also work as an identifier, but we are using the identifier which MS Access is adding in our table. Then you have nation name, and exchange rate is an important information here. So every country will have its own exchange rate, and that exchange rate is related with the stock. Okay, so the ID of the country, code of the country, name of the country, which is nation name, and the exchange rate. All this information we have in nations table. How about shares table now? In the shares, we have an ID, which is an identifier for the share. Then you have the code for the share, name of the share, price, quantity, dividend, PE. These are all the same attributes that you had in your previous share file. But here we have one more column that we added. And I went over this concept that when you have to implement one-to-many relationship, then you need to add something called as foreign key. Alright, so you add a foreign key in the many side of the relationship. So many side is shares here. So you added a field, we call that as nation ID. And in the nation ID, the values that we are putting is the primary key value of the nation table, right? So for all those shares that which are listed in United Kingdom, we are putting the nation ID as 1. And similarly, for United States, we are putting the nation ID as 2. For Australia, it is 3, and for India, it is 4. Okay, so this exercise we have done, we did in the last lecture also. Just for the sake of completion, we have that information here again. So now what is happening here? The data of our interest is split into tables. The country related information is in nation table, and the shares related information is in shares table. But we did keep this thing in mind that in future we might have to combine the information between these two tables. So for that reason, we added one more field, which is nation ID here, that we called as the foreign key. All right, so now here the data is in two tables here, right? When your data is in multiple table, then in order to write a query, you will have to join the tables. All right, so I will explain to you this join operation. Okay. All right, so let's think about writing a query. So what I intended to do was I want to take you to the MS Access, and let me write some queries and explain to you how we should be writing a join, and then I'll come back to my lecture slides, and I'll discuss from lecture slides. Okay, so access. In the access, I already have this database that I created in my previous lecture, which I called as one-to-many, because this database will give you the demo on one-to-many relationships. So you have this table nations, and you have the table shares. I would request you to rename the attributes of these tables, because I think originally the shares name is firm name, and code is, I believe, firm code. So if you change that in accordance with the name that we have in our lecture, then it will be a lot easier for you to try the queries that I have in my lecture slides. So that was one thing. One point is to rename the attributes of your table such that it matches the name that we have in the lecture. Why? Because then you can try the queries that I have in my lecture. So that was one thing. And there was another thing that I mentioned to you in my last lecture, which was about making sure that the data type of the foreign key, right? So how do you check the data type of the foreign key? Foreign key is nation ID, right? Come here, look at it, and it is long integer. By default, if you don't change it, then it will be number. Alright, it will be a general number. It won't be a long integer. It will be a decimal probably. So decimal or double, I don't remember, but you have to change that. You have to change this attribute to long integer. You should ask me, why are you asking me to do it? I'll say the reason being, uh, the value that you have in nation ID should match the value that you have in the ID field of nations. Alright, so to double check what type do we have for ID field, it's long integer 2. So these types should match, otherwise it will not work. Alright, so these things I asked you to do, and the exercise that we did was we created this RDM. Okay, so these are the things that we already tried in the previous lecture. Now let's create a query. Alright, so we'll go to the query wizard. I'll use simple query, and let me take everything from the nations table, say next, and finish. So what I'm trying to do, I want to use query wizard. Alright, so I will use query wizard for writing my queries. And very simple query I have written where I want all the information from nations table. Alright, so it's very simple query right now. Let's match that. 4 rows. Okay, I didn't change anything because my query is very simple, involving one table. I don't have any restriction. I don't have any group by where having all those stuff that we used. I did not use any of those. Now let me tell you about one thing, which is select star from nation. So this is something we have been doing. You can write one more thing here, which is shares. So earlier when we were dealing with one table, we used to specify that table in the from clause. But now when you have to deal with multiple tables, when your data has to come from multiple table, then you can keep those multiple tables in your from clause. So what will change? You'll have more tables separated by a comma in from clause, right? So let's see what will happen. So when you run this thing, you will get some output. Okay, so this is not an error. This is not an error at all. You will get some output. But what is that output? Let's try to understand. So when you're saying select star from nations and shares, so what will happen? All the data that you have in nations as well as shares are combined. And what happens is a kind of a Cartesian product. Okay, so I'll explain to you what is a Cartesian product, or let me take you there. Cartesian product, okay. So before the join, we should know about Cartesian product. Cartesian product, and this discussion is in context with SQL. So when you have two tables, right, let me create some table A and table B, and here you have two attributes. You have the attribute A, you have attribute B, and you have attribute B and attribute C. Alright, and let's put some values for table A and B. So the table that we have here, the values that we should have are like this: A1 B1, A2 B2, A3 B3, and let's put B1 C1, B2 C2, and then B4 C4. Okay, this much should be fine. So now when you do an operation like this, when you something that I tried, when you say select star, from A and B, so the result would be a Cartesian product of these two tables. So let's try to understand what is the Cartesian product. So the result would be the columns like AB from table A and BC from table B. Alright, and we will have 1 2 3 1 2 3 9 rows, 3 by 3 9 rows. And what information will we have here? You'll have something like this: A1 B1, B1 C1, A1 B1, B1 sorry A2 B2, maybe I should keep A1 B1 and B2 C2, B2 C2, A1 B1, B4 C4. So what is happening here? You take one tuple from table A and generate all the combinations that you can with the corresponding tuples from the next table. So for A1 B1 you will get these three tuples, alright, combining the different tuples from B. So you can do the same with the second tuple starting from table A. You should have A2 B2, B1 C1, and then A2 B2, B2 C2. Okay, then A2 B2 and B4 C4, and then you'll start with A3 B3, A3 B3. Let me write A3 B3, all the A3 B3. Then you will have B1 C1, B2 C2, and B4 and C4. So that's the result of Cartesian product. You are generating all the concatenation also, you can say. You are concatenating all the possible tuples, all the possible permutations you are generating. A1 B1 with all the three columns of table B, A2 B2 with all the three rows of B, table B, and similarly A3 B3 with all the three rows of table B. And that's how you get 1 2 3 4 5 6 7 8 and 9 rows, right? So which is not meaningful, right? If you say that, what did you gain? I did not gain anything. I just got Cartesian product, which is meaningless. Alright, so let me use the eraser to remove some clutter. I hope you got this thing that I was trying to convey. Cool. So I should go back to my pen. Should rather use mouse for that purpose. Good. Right, so the understanding of Cartesian product is important before we learn about join. Okay, so what you should do, you should argue that, I should remove this box as well. Remove this box, and now it's better. Okay, right, so I hope you understood what is Cartesian product. What we should be doing, rather than computing something like this, we should look for a column which is in common between table A and table B. So that column is, or that attribute which is in common between A and B, is the attribute B. right? So when we are combining these two tables, then I should only combine those rows that match in terms of the value of b. Okay, so I should be only interested in generating this combination because these the value of b attribute is matching, and then this one because here also the value of b attribute is matching in between the tuples of a table and b table. And this I should not generate because here this b3 does not match with any tuple in the table b, and similarly b4 in the table b does not match with any tuple in table a in terms of the attribute b. Okay, so if you follow that, then what I am trying to say is that I should only be interested in returning the tuples like this, where the attributes the value of the attribute b in both the table are matching. This I should be interested in getting. This I should not, because b1 is not equal to b2. Similarly, this is not meaningful to me. This is not meaningful. This is meaningful because these two match. b2 values in table a and b are matching. I don't need this guy because b2 is not equal to b4. Similarly, right? So I should only get these two tuples in my result when I combine the two tables. Alright, so this kind of a logic that you have where you combining two tables on the basis of the same value of the attributes from table A and table B is called the join operation. Okay, so the join operation is kind of um, uh, defined on Cartesian product. So that was the reason I went over this exercise of telling you about Cartesian product. So join is defined on, sorry about that, here we are. Join is defined on Cartesian product. Cartesian product. I will explain to you what I mean by that. So this thing that you have done here is just the Cartesian product. I can extend that and I can make that a join. So how should I make that a join? I need to add some more detail here so that instead of getting all these 9 tuples, I should only get these 2 tuples, right? So how to do that is very simple. We will use the clause that we already know, which involves restriction. So we will use where. Select star from A and B where what? A period B is equal to B period B. Let's try to understand what do we mean here. So this fact, right, I had used B. This is used to tell that I am referring to the attribute B in table A. Okay, and similarly when you say capital B period B, that means you are referring to the attribute B which is present in table capital B. Alright, so sometimes we use this period operation for to avoid any ambiguity. So what is happening here, we are interested in retrieving all the columns information from table A and table B only where the value of the B attribute matches in between table A and table B. Okay, so that's the join operation. Alright, so hope you are following this thing. I will add one more note here and then I'll take you to my lecture slides. Okay, so here what you have done is called, this way of making a join is called implicit join. Implicit join. Alright, you can also do something called as explicit join. So let me use this portion. Explicit join. What is explicit join? Okay, so let's have a look at that. So I will do the same operation, right? I want to join these two tables on B. I can say select star from, now the things will change slightly. You will say A inner join. I don't have a space, so I'll take it to the next row. You should say from A inner join B on. So that's the syntax. You should say select star from A inner join B on A dot P equals B dot B. Alright, so this is called explicit join because you use this term which is inner join. Right, you are saying that we have to perform a join operation. So you're explicitly saying that, I want to select these columns, but before that, I want to perform an inner join between these two tables, and you use the clause from, similarly the way you had from here, but you should explicitly saying that I want everything from the result of inner join between A and B, from A inner join B on the join condition. What's the condition? A dot B is equal to B dot B. Alright, so this much I wanted to explain to you by using a whiteboard, but don't worry, I have everything in my lecture slides also. Alright, so I will keep this and I'll take you to the demo. Alright, so what did we do? Nations query, this is what we had written, and when you're right here, let's run this. So what you got here is the Cartesian product. So you can verify that, here you have nation ID as UK as 1. So this is being connected with all the, so see, this is something that you may not like, nation ID USA. So why are we combining the US tuple with the share which is Fredonia copper, I believe, and Fredonia copper is a share which is in USA, right? So no, sorry, Fredonia copper is in UK, but right here in the query that you have, the Fredonia copper is coming with USA also, with Australia as well, with India as well, right? So these things are meaningless. So very often the Cartesian product gives us a meaningless information. So we need to be, we should be writing a where clause for join. So how do we do join? So for join, I should say nations dot id equals shares dot nation id, right? So here we are comparing the foreign key. Nation id is the foreign key in shares. Nation id right here, it is the foreign key in shares. It should be equated to, or it should be equated to id field of the nation. So that's the uh, determinant or primary key. Alright, so now I have written the join. So if you run this one, then you will get some meaningful information, right? Yeah, it makes a lot of sense. You can compare the id field here with the nation id field here, and you will see the perfect agreement, right? So this is what we wanted, and this is join operation. Well, either you can do the join in this way, or you can do it in explicit join. So this is my favorite question. I ask questions in exams on explicit and implicit join. I'll give you implicit join that you have right here, and I'll ask you to write the query using explicit join. So you should do that practice. So how do you change this to explicit join? You will say select star from nations inner join, right? Inner join shares on Okay, so this is explicit join. You'll say select star from nations inner join shares on nation.id is equal to shares.nation.id. Let's run that. Okay, so the same result. The only thing which we have changed is that we made our join explicit. Good. So now I believe I should take you back to the lecture slides and let's discuss from where I left. Alright, so let's see. What do we have here? So here it's a simple query where we are selecting everything from shares and nation, and here you are doing implicit query. Alright, so I believe that whatever I explained to you using a demo, same thing you will find in my lecture slides right here. Okay, let's move on. Alright, so what do we have here? Well, this is the revision of what we have learned. In one-to-m relationship, one-to-m relationship is provided with a primary key foreign key pair. We learned that. Sorry, I think I should have used pen. Alright, so this thing we have learned in our previous lecture and we revised that as well. Each foreign key must have a matching primary key, right? And what is that called? Each foreign key must have a matching primary key. What is this thing called? You know, you can have a question like this in exam. So for that you'll have to go back to my previous video lecture and you will find something like this. Referential integrity constraint. This is called referential integrity constraint. Alright, yeah. And every primary key must be null, right? This is also very important. Primary key cannot have a null value. Every primary key must be a non-null value, and this is sometimes called as primary key constraint, which means that if you're defining something as a primary key, then you cannot allow a value to be null. I mean, you cannot allow any record with the null value for the primary key. That's called primary key constraint. And every pair must have the same type, right? If you remember, I told you about it, like if you don't ensure this thing, then you will have tough time even creating the RDM that we did in the last class, right? So you know, let's see, a common but hard to find error when you are first starting, right? That the key pair must have the same type. So you should say, what do you mean by key pair? So here key pair means the primary key and the foreign key, corresponding foreign key pair. So that's the pair we are referring to. Like ID field of nation is the primary key and nation ID field of the shares is the foreign key. So these two should have the same type. Otherwise you'll have the problem. So we fixed that, right? Before creating that RDM, we made the nation ID field as the long integer, which is the type of the ID for nations table. Okay, so what do we have here? When modeling an ER diagram, we omit the foreign key attribute since it can be inferred from the relationship arrow. So yeah, this information is usually not provided in RDM. You can provide this information. You can provide the information about primary key, but um, um, giving any information about foreign key is difficult, and often this is not provided in the RDM, and this is something we kind of conclude from the relationship arrow. So that's the point. I already went over it. Now let's look at some join operations, okay, and try to understand like how are the queries going to be different in this case when we have multiple tables. So it is up to you. How do you want to learn about it? If I have to learn about it, I will copy this query, take it to the MS Access query wizard, type it out there and play with that. Okay, so it's up to you. Do you want to just read it like English statement and understand it, or you want to treat it as a program and run the program and see how things are changing? So what are we interested in finding out, right? Let's see. The select clause of the select statement lists all the attributes which we will be looking at in the final result, and this is called projection operation. So the whole data and the data is coming from, you should look at the from clause, and from clause will tell you the source of the data. So select followed by the attributes will tell you what attributes you can see in the final output. And when you have from, then from will tell you like what are the source tables for your query. Here we have two source tables, shares and nations. And then let's look at the next clause also. When you're taking the information from these two tables, shares and nations, then are you performing any join? Yes, the answer to that is yes, we are doing join. How we are doing? Where shares.nationid is equal to nations.id. So this is implicit join. Okay. So there's another interesting question, like which one is more efficient? Is implicit join more efficient than explicit join in terms of the speed? I will say no, right? As goes the efficiency, these two are same. Implicit join is same as explicit join. Only during the debugging, explicit join is considered better. Explicit join is considered better when you perform multiple table joins. Say if you have three or four tables that you are joining in the query, and you do that with explicit join, then finding out the bug and debugging it is a lot easier when you use explicit join. When you're using implicit join, often you are stuck in some error, and that is very difficult to fix. So that's the advantage of explicit over implicit. Efficiency wise, these two are same. Alright, so order by nation name and share name, that means once you have the result, you want to do the first sorting on the basis of the nation name, then followed by the share name. So these things are very simple, okay? We know that we have two tables, so we are using from, we are using where clause for join operation, implicit join operation. And let's look at select, like what are we doing in select clause? So we need nation name, which should come from nation table. Share name is coming from the shares table. Price is coming from shares table, so let me write S as for shares table. Quantity is coming from the shares table. Exchange rate is coming from nations table. Nation name is coming from nations table. All right, and we want to compute something. So this expression that you have, it corresponds to a derived attribute, right? So derived value, and this derived value is derived from price, quantity, and price and quantity is coming from the sales table, whereas the exchange rate that you have here is coming from your nation table. And this is my N. So this price multiplied by quantity multiplied by exchange rate, we'll call that as stock value. So we are computing stock value for every share that we have in a country. So nation name and the share name, the price of the share, quantity of the share, exchange rate, and then the stock value. So these are the values that we need from the two tables. Okay, and if you type this correctly, then you'll get the output like this, right? And here you have, Australia, the share name, the first one that they had, okay, the Ruby one. Then you have the price, quantity, exchange rate you got from the nations table, and then the stock value you just computed right here. Okay, and you have renamed that as stock value. So all these things we have learned in our previous lecture when we looked at the SQL queries in some detail, right? SQL query involving select is, I should say, select SQL query in detail. Okay, so I believe it's not complicated. What you need to do is practice. Okay, so one of the practice that you should do right here on this slide is, let me write that as an assignment for you. Do it Do it means do the above one with explicit join. I love these kind of questions in exam. Alright, so I will not give you any hint, just a question. Do it with explicit join. There should be something you should be using inner join keyword. Use inner join keyword. Alright, okay, so let's move on to the next slide. Okay, so when you do the join, then you might see some repetition in the value, right? So see, for this value that you have, the UK and nation name has been repeated for multiple shares. So this is something which will happen unless you do some summarization. If you're doing summarization, then this will not happen. Otherwise, temporarily, so what will happen when you do a join operation, then temporarily uh, a table, a combined table would be created that will be holding the result of the join operation. Okay, so temporarily that is done, and after that, once the query is completed, that table is gone. Okay, so that's a problem, and you can have some redundancy like this because of join operation. Okay, so now let's look at some query involving group by. Alright, so let's say report by nation the total value of the stock holding, and the value of the stock holding is computed by price into quantity into exchange rate. So let's write this from scratch. We have to report the by nation the total value of the stock holding. Value of the stock holding is price into quantity into exchange rate. Okay, cool. So say keep, and let me take you to access. What do we need? We need nation name. If you want to be, you can say nations dot nation name, right? It's a good practice to have the name of the table, a period, and then the attribute name. That's the best way to go about it. So nations dot nation name. I want this, and then I want shares dot. You have price, you have quantity, right? So nations dot price multiplied by shares dot quantity. Okay, we need price, we need quantity, and then we will need the exchange rate. Exchange rate is something which will come from nations dot exchange. This is a problem with me. Exchange rate, nations dot exchange rate. Do we have that? Yes, we have exchange rate as stock holding, right? Let me see, what are we calling that? Stock holdings, right? Which is price into quantity into exchange rate. Price into quantity into exchange rate. We should use capital letters for keywords. From nations inner join shares, right? So whether you say from nation shares, and then you say where using implicit join, or you can do explicit join. So I will use explicit join. From nations inner join shares on this thing. What else do we need? It is to be grouped by nations, right? So I should have a group by nations dot nation name. Let's run that. Okay. Alright, so that's a problem. You are saying that total, right? So we should have a sum. We need to apply an aggregate function on that, because the query says that you have to find out the sum of the stock holdings for country wise, right? So country wise sum of stock holdings. So since we are doing group by nations dot nation name, so we need to group that nation wise, and then for each share of that nation we will compute the price multiplied by quantity multiplied by exchange rate, and we'll finally sum that up for each country. Okay, so yeah, we got it, right? So probably that's what we were looking for. 946, 85. Great. Okay, so it was not difficult at all. The only thing is that we need some practice, and I believe it should be fun, right? SQL, I think, is fun. If you like too much of programming, then yes, you may not like SQL because it's declarative, right? We just say what we need. We do not specify how this value should come. All right. So yeah, if you want to, what we did right here was using um, the SQL query thing. We wrote the query and we found the output. If you want to try that out in the design view, you can look at the design view as well. Alright, so here it seems to me that we have the count as well. So what I should do, since I've written it, I will take you to the design view, right? So in the design view we have the RDM as well as the corresponding query in the design, the corresponding query in GUI mode. We learned about GUI thing also, right? I think previous to previous lecture we did that. Well, since that thing has, I can have one more thing, right? As count star. All right. So what I did, I am trying to have the same query as count stock. So I'm adding one more, attribute in the result, which is counting how many stocks do we have for each country, right? So the reason why I'm doing it being that I want something like this, okay? It is very close to what you see in the lecture slide. You have share count. I should have called it share count, but that's the same thing. All right, so you're getting count as well as share value. You are getting count as well as the stock holdings or share value. All right, so you might have got this thing till now that we need to be careful about join. Rest of the things are very similar to what we have already learned when we were doing single table query. Okay, let's move on. Now you have these exercises like are we on track, and this is where I always recommend you to pause the video lecture, try it out yourself, because this is online lecture where I can't force you to do it, right? In my in-person lecture, I would stop my lecture and I'll ask you to do it, and then we interact. But pause it right now and see if you can write a query for this task, which says that you need to report the total dividend payment by nation. And remember that the total dividends is shares multiplied by dividend per share. How will you write that? Okay, pause. Well, anyway, I need to do that, right? Let me give you a demo to how to do the same thing. We need total dividend nation-wise, right? So what should I change here? I need nation name. I don't need counts. This thing. Do we have average or total? Total dividend. Okay, so sum shares dot price. No, I need shares dot quantity multiplied by shares dot dividend. Dividend. D-I-V-I-D-N-D. Dividend. I hope this is fine. Dividend. Yes. I Just I had a capital D, it may not make much of difference, but that's okay. Quantity as total dividend, total dividend from nations in a joint share on nation ID is equal to share ID group by nation dot nation name. I don't think I need to change anything right here. Alright, let's run that. Okay, so seems like a very simple query. We will compare our result 54. Okay, why is that the case? India 38. Total dividend is the shares multiplied by dividend per share. Alright, let me see if we missed out anything. You have nation's name, sum, shares dot quantity into shares dot. You have quantity and you have dividend, right? So that's what we want. Total dividend, shares multiplied by dividend per share. I think that's what we are doing. As total dividend from nation. Okay, so let's see if we have anything different in this thing. Okay, sorry, I missed that. We need exchange rate as well. Alright, so the exchange rate was missing here. I apologize for that. You need to have nations dot exchange rate. Alright, so let's run that. And now I should compare. Now it is matching. Okay, Australia has 54,426, India 3. Yes, right? Yeah, I got it. Alright, so it was simple exercise, I'll say, and I will highly encourage and recommend you to do these things. Okay. Alright, so that was the exercise. Are we on track? Now, here you have this discussion that I had earlier in the lecture, which was about the difference between explicit join and implicit join. In explicit join, you do use this keyword. We use a keyword in a join. Alright, so you will specify table. You will say table 1, then you use the keyword in a join, right? Then you use table 2, and then you use the keyword on, and then you have this condition, like what is the condition which you're using for joining the two tables. What pair of the primary key, this is primary key, and the foreign key you are combining. Okay, and with implicit join it's fairly simple. You just need to make use of a where clause, and in the where clause you will map the, here it is foreign key first with the corresponding primary key. Alright, now let's look at having clause, right? So report the total value of the stock for nations with 2 or more listed stock. Okay, so I think we should know how do we define price, quantity, and exchange rate. Okay, so having is important here, right? And we want this information for nations with more than 2 listed stocks, right? Let's see how will we do that. So we are imposing another condition on that, right? So do you know how to impose that? Well, we will use having. Having what? Count star, sorry, greater than 2. already we were doing this computation, right? So we were computing nation name, and this should have been renamed. This is not total dividend, or probably this is total dividend. We'll figure out what we need here. We need price, quantity, exchange rate. We need quantity, price, right? Price. In the query we are finding a different value. We are not finding total dividend, so let me change that, and I think we call this stock holding. Stock holding. Don't worry if you don't follow these terms, I don't follow either, but yes. Alright, so we have to compute the share quantity multiplied by price multiplied by nation exchange, nations.exchange rate. We call that stock holding. This is to be done nationwide, so we'll have to group by nation name, and we need to do join here. We are performing explicit join by using the keyword inner join. And the most important thing, which is different from our previous queries today, is the fact that we are using having. Why having? Because the query says that we want it only for the nations with more, two or more, right? So 2 is to be included, so I should say greater than or equal to 2. So having count star means what? When you are doing the summation, right, when you're doing this aggregate function, which is summing up this quantity which you compute for all the shares which are there in a country, you're also finding out the count, like how many shares do we have listed for this country, and we are only reporting the value in the output for the country and that has more than 2 shares listed there. Let's run it. Okay, so we are Australia, United Kingdom and United States. Let's compare that. Australia, United Kingdom and United States. So hope the values are same. Yes, that looks same to me. Okay, good. Sorry about that. Let's move on. All right. So okay, so few more examples. So this example is fairly simple, so I will not type that on MS Access. I'll leave that as an exercise for you to try it out. So the scene is that, we did look at the query with subqueries when we were doing queries on one table. So similarly, when you have multiple tables, you can also make use of subqueries. So right here, the query that we are writing is for reporting the name of all Australian stocks, right? So how can you do that? Well, there is a simpler way, but in this case, we want to use a subquery, all right? Because we want to try that, will this thing work with the subquery or not? Okay, so how do we do that? Excuse me. So the country name, which is Australia, this is something given to us. We only need the stocks which are listed in Australia. Now this national information is only available in nation tables. So in shares we did not keep the country's name. So we are forced to have a join operation between the shares table as well as the nations table. So what do? We will say select shares name from shares where shares.nation id ends. So we are kind of doing a, I should not say join, we are writing it in a very interesting manner where we are looking at the shares id and we only want the shares id for those shares whose uh, name happens to be uh, Australia. All right, so how did we attain it? Let's look at the inner queries. So whenever you have subquery, then in order to understand the subquery or to write a query with the subquery, first we should understand the subquery. So let's see what are we doing in the subquery. In the subquery, you are selecting the ID of the country with the name Australia. All right, so we are finding out the ID for record in the nations table which corresponds to the country Australia. So that is something you'll figure out with the inner subquery. And when you know the ID of the Australia, then you can compare that ID value for Australia with the foreign key value for the shares. And you only want those shares whose nation ID matches the ID of Australia country, right? So that's what you did. You compared the nation ID of the shares table to the ID value of Australia, right? So your inner query is finding out the ID for Australia, right? You're doing select ID from nations where nation name is Australia. That's what you did. And once you retrieve the ID for for Australia, you just compare that ID with the shares in the shares table. Okay, and that ID information anyway you have in the nation ID field, which is your foreign key in the shares table. All right. So now interesting thing is that the same query which we wrote in slightly complicated way using a subquery can be easily written in this way. Alright, so what you will do, we will do a join. Let's see. You will say select shares.share name from nations in a join shares on nation.id is equal to shares.nationid and where nations.nation name is equal to Australia. Alright, so it was fairly straightforward. But here in this case, we are doing it using explicit join. So I'll give you another assignment here. Okay, so the other assignment would be do it with implicit join. Okay, so here you have explicit join, you're using inner join. Okay, yeah, that's the best way to prepare for the test and in order to develop your skill as well. Okay, so now we have this Are We On Track exercise one more time. Report the average yield by nation. Yield is defined as dividend divided by price. Pause again and do this exercise and make sure that you got the answer that we are looking for. And it is to be reported as percent. Okay, so that's a trick we'll learn later. But first write this query, not thinking too much about the format. You need yield. You need the average yield by nation. Okay, so pause and do that exercise. Let me do it for you so that you can double check. We need average yield by nation. Yield is defined as dividend divided by price. I'll go here, the average yield. I should call AVG, average yield. Okay, and average yield should be AVG. And how do you find out yield? Yield is shares divided shares dividend divided by shares dot price. Alright, we don't have any condition like this. Shares dot dividend, shares dot price. Shares dot price. Okay, cool. So looks good to me. Let's run that. So this is something you will find, but a lot of hashtags does not mean that you have an error here. Just make it a little bigger, right? The only problem is that the value is float, and this guy is trying to express that in the best possible way. So how to fix that? If you go back here, we want that in the percentage. So what do? We go to the design thing. Yeah, pick this column that you want to fix. Change the format to percentage. Alright, run that. Okay, so now you should get what you're looking for: 6.22, 3.91. So all these skills will help you when you're doing your project. And we will very soon discuss the project. Probably I'll post your homework very soon, maybe by tomorrow, and then after that, probably in the next few lectures, I will discuss about your project, and you should get started on that. Okay, so that was the exercise, and then for some reason the views are reappearing. So views are virtual tables. We'll discuss about views later. And the good thing about views is that views are virtual tables because they are not created permanently. They are only created for some queries. If we want to perform some query or some join operation multiple times, then it is considered a good idea to create a view corresponding to the join operation, so that the result of those join operations are saved as a virtual table, and later on when someone has to do the same join operation, then rather than doing the join and then querying, what we do, we query the virtual table. Okay, so all those things I will discuss in detail in the later chapters. Now, how about this? Did we meet the objectives? Yes, we did. I will say we did write some queries involving one-to-many relationships, and these queries were starting from very simple queries to slightly more complex ones involving the group by and having clause. Okay, so yes, we are done, and I'll see you in the next lecture. Please do all the exercises and take care. Bye bye.